Hey everybody, we're going to go over the last section of chapter 11 today, and we are going to be having our first test next week over all of chapter 10 and all of chapter 11. So we'll talk more in person about what that looks like and what that's going to go over and everything. But for now, we can just go ahead and get started on the notes. So we're going to start out of section 11D. We're going to be talking about simple discrete data. And as a reminder to you all, discrete data is the counting data. It is the data that you can easily count. And so for simple discrete data, we like to use frequency tables to organize this stuff. Now, a frequency table is typically just going to look like this. You have whatever your value is. You can have a tally count for how many occurrences that have been, as well as I'm missing a tally there actually, as well as the total down here, and then make sure to include the relative frequency. But when we talk about a frequency table, this is what we're referring to. And so another way that you all can display this data is using a column graph, which is basically just a bar graph. So you just make your possible data values your x-axis, you make the frequency your y-axis, make sure the columns are equal width, and you're good to go as far as graphing those. One of the things that will come up a lot in the problems we're going to work today is what is the mode. As a refresher, the mode is the highest occurring value, and then some language for how we talk about the shapes of data sets. If you draw like a curve around your bars here and it looks like it's pretty close to even on both sides, we refer to that as a symmetric distribution. If it looks like the negative side of the graph here is stretched, so we'll say negative side is stretched, we have what's called a negative skewed graph. And if the positive side here looks like it is stretched, we call it positive skewed. So just some vocabulary to get us started. There's going to be a little bit more math or statistics involved today than there was last class. Last class was a lot of vocabulary. We'll get started on some actual mathematics here in a second, though. So we have this concept of an outlier, and there is a mathematical way to prove an outlier, but we're not there just yet. But an outlier is basically just data separated from the majority. It can be high or low, and whenever you are collecting data, you have to decide whether to include outliers or not, because outliers can appear because they're genuine. For example, it could be that if we're measuring height of everybody, that someone's like 7'6" or 4'4", and they're like genuinely that tall. But outliers can also occur due to human error if you make a mistake in graphing or data entry. So like if you were typing in all of your numbers, you accidentally typed one in. So you have to be the one to decide whether it's worth it or not. So we're going to get started on an example here of creating a frequency table and constructing a column graph. So feel free to hop along in here with me. I have included copies of these notes on Canvas, so if you want to print those off and hop in with where I'm at, that's perfectly fine. So we've got 30 children who attended a holiday program. Their grade levels were listed here, and we want to go and make a frequency table for this data here. So let's see, we're going to have to make some different columns here. We've got the year level. So let's see, it goes from 6 to 7 to 8 to 9 to 10, and I did not give myself enough room for that one 11th grader, that one freshman, or that one junior. Oops. It will be all right. We'll figure out something here in a second. So we're going to tally, and then we'll list the actual frequency here, and then we'll list the relative frequency here. So let's see, there are 6 sixth graders, 9 seventh graders, 8 8th graders, 4 freshmen, 2 sophomores, and we're just going to squeeze in an 11 here, and there's one of them. That's just going to be Mr. Price's fix for that. So if we're making tallies for that, 1 2 3 4 5 6, 1 2 3 4 5, 1 2 3 4, 1 2 3 4 5, 1 2 3, 1 2 3 4, 1 2, and then just a single one. And then we're listing the relative frequency here. That's just out of how many total does this occur. So if we've got 6 out of 30, that is 0.2. If we've got 9 out of 30, that is 0.3. If we've got 8, that's going to be approximately 0.267. If we've got 4 out of 30, that's going to be approximately 0.133. 2 out of 30 is 1/15. That's going to be approximately 0.067. And then the last one here, 1 out of 30, that's 3.33%, so 0.033. So this acts as a way for you all to organize the data. So then to display the data, we've got to construct a column graph or a bar graph, whatever you want to call it. So let's see here. We're going to go 6, 7, 8, 9, 10, 11. We're going to do year level here. And then what's the highest frequency we had? 9. We can go 2, 4, 6, 8, and 10. And then we're just going to construct a graph for this. So you can go ahead and pause this and make yours if you're pretty confident that you can do so. And we can keep it going from here. So 6 is going to go up to 6. 7 goes up to 9. 8 goes up to 8. 9 goes up to 4. 10 goes up to 2. And 11 goes up to 1. So that's how we display simple discrete data. So then we're talking about what is the modal year level of the children. What is the most commonly occurring one? That is 7th grade. We want to describe the shape of this distribution here. So again, if we make a curve like that, we want to answer the question, which of these three does it look the most similar to? And to me, that looks like it is positively skewed. We've got this part stretched out here. So we're going to say it's positively skewed. And with all this data being clumped together, it doesn't look like to me that there are any outliers. So then we can also use simple discrete data to answer probability questions or percentage questions. So this one wants to know what percentage of children were year 8 or below, as well as what percentage above year 9. So let's see, percentage of children were year 8 or below. We had 6, 9, and 8. So we're going to add those together and put that out of 30. So get the relative frequency of those three together. So that's going to be, I believe, 23 out of 30 or 76.7%. So then for above year 9, we've just got the sophomore and 1 junior out of 30, which should be 10%. So again, I don't think that this is anything mind-boggling that we're going over today, but I did want to go over it with you all just so that we could be certain. So we're going to go through 11E, and then we'll finish up with 11F, and then we will be good to go today. Now, the only things that you all need to know from 11D here are that if it's grouped discrete data, so in situations where you've got a bunch of numbers here where they don't occur frequently, so like we got 27, 30, 17, 13, 46, 23, 40, 28, 38. If all of your data is not super close together and not common, it's better to graph it using intervals and to classify it with intervals. So instead of saying I'm going to put a tally for every 9, we're going to make intervals from 0 to 9. We're going to make intervals from 10 to 19 and count how many occur within that. And so all of this is the frequency table looks the same. The group discrete data, the column graph, the bar graph looks the exact same. It is just the interval that is different. So I'm not going to spend a whole lot of time going over anything from 11E. It is basically 11D, just with intervals instead. And so moving on to continuous data here. As a reminder, continuous data are things that can't necessarily, they can be measured but not necessarily counted, such as like time or weight or distance. All of those things can be measured, but they can't necessarily be counted like 1, 2, 3, 4. And so whenever we're measuring continuous data, we're going to use what's called a histogram. So if you haven't seen a histogram before, it's basically the same as a bar graph, basically the same as a column graph, except all of your columns are going to be pushed together. So we're going to look at an example from page 298 for you all. So we're looking at a sample of 20 juvenile lobsters. These lobsters are, I don't know why they use the word juvenile. That made me chuckle when I read it the first time. So the lengths of these lobsters were as listed below. And so the first thing that we want to do is organize the data using a frequency table, and then we're going to graph this data. So the frequency table here that we're going to be using is going to largely look the same. So I'm going to look at this data real quick. It looks like the lowest is 3.1. The highest is 7.3. So I'm going to start at 3. So we'll say, okay, the length here, we'll say is from 3. We'll include 3 for the length, and then we won't include 4. So where this is continuous data, it's going to look a little bit different than the intervals for discrete data, because there's going to be a little bit of overlap. So 4 is not included here, but we're going to say 4 less than or equal to the length is less than or equal to 5. So 4 is included for this interval. So if it's 4 on the nose, it's going to get counted in this interval. So we're going to finish writing these out. 5 is less than or equal to the length, which is less than 6. And then same thing for 6, less than or equal to length 7. And then 7, we've got to go all the way to 8 here. And for the frequency here, let's see, if we're counting the ones between 3 and 4, there's 1, there's 2, and there's 3, so there would be 3. If we're counting the ones between 4 and 5, let's see, 1, 2, 3, 4, 5, and 6. Now, if we're counting the ones between 5 and 6, this 5.0 gets included in this one, because 5 is less than or equal to the length for this interval. So we're going to say 1, 2, 3, 4, and 5. Let's see here. From 6 to 7, we've got 1, 2, 3, 4. And then that'll leave us with 2 at the end here. So the way that we would display this here is when we're creating a histogram, because it's continuous data, all of this stuff has to be clumped together. So I'm going to put a little break in the graph here so that we can have it start at 3 to 4 to 5 to 6 to 7 and to 8, and then 2, 3, 4, 5, 6. That'll work. Gave myself enough room. So from 3 to 4, we'd say, all right, this is going to go up to 3. From 4 to 5, that's going to go all the way up to 6. From 5 to 6, that's going to go all the way up to 5. From 6 to 7, that's going to go all the way up to 4. And then from 7 to 8, that's going to go all the way up to 2. And the important part is you have to make the distinction that this is a histogram because all of this data is running directly together. Whereas before on the column graphs, we didn't have to because it was counting data. There's numbers in between your counting data that we can't necessarily count. So then the next thing that we're going to do here, state the modal class and explain what this means. So the modal class here is just the tallest bar, the most occurring one here. So this guy right here. So more lobsters were between 4 and 5 inches than any other interval. And then the last thing here, if we want to talk about the distribution of this data right here, if you draw a curve and we're asking what kind of curve does that look like, that is a positively skewed graph. So again, I know probably not the most difficult concepts today, but they are things that will pop up on your IB exams. So I just wanted to make sure that we covered them. So if you all have any questions at all, you are welcome to ask me on Zoom or shoot me an email, and I will see you all next class. See ya.